Hi everyone, I'm Pelinjo, an AI researcher in Upstage. I'm so glad to introduce our SIGR 2022 paper, Decoupled Set Information Fusion for Sequential Recommendation to you. We are living in the age of information overload. Recommendation system has been regarded as one of the best ways to deal with such problem. Here, we focus on the topic of sequential recommendation, whose goal is to predict the next item the user will interact with based on his or her behavior sequence. During past years, multiple deep learning-based solutions have been proposed, and self-attention-based methods become mainstream solutions with competitive performances. And most of these methods just use item ID to represent a behavior. Recently, some work tried to take set information, such as item attributes, ratings, and etc., into consideration. Intuitively, the highly related information could be utilized to boost the recommendation performance. However, how to effectively fuse that information into the recommendation process remains a challenging open issue. Some researchers propose to integrate the item embedding and set information embeddings before the attention layer to enable set information aware attention. For example, ICAI-SR utilizes attribute to item aggregation layer before attention layer to integrate set information into item representation with separate attribute sequential models for training. And SUSREC-F is an extension of SUSREC. This model fuses the item and attribute representation through concatenation operation before feeding them to the model. And NOVA proposed to feed both the pure item ID representation and set information integrated representation to the attention layer. And the latter is only used to calculate the attention key and the query and keeps the value non-invasive. Despite the remarkable improvement, early integration-based solutions still have some limitations. First, we observed that integrating embedding before the attention layer suffers from a rank bottleneck of attention matrices, which leads to inferior attention score representation capacity. It is because of the fact that the rank of attention matrices of previous solutions is inherently bounded by multi-head query key down projection size DH, which is usually smaller than the matrices could reach. Second, the attention performed on compound embedding space may lead to random disturbance, where the mixed embeddings from various information resources inevitably attend to unrelated information. And the similar drawback for positional encoding in input layer has also been discussed in NLP papers. Therefore, we propose decoupled set information fusion for sequential recommendation. The main idea is we just move the set information from the input to the attention layer and decouple the attention calculation of various set information and item representation, which is inspired by the success of decoupled position embedding in NLP. And our proposed framework consists of 3 modules: embedding modules, decoupled set information fusion module, and prediction module with auxiliary attribute predictor. In the embedding module, the input sequence is fed into the item embedding layer and different attribute embedding layers to get the item embedding and set information embeddings. And the decoupled set information fusion module contains several blocks of sequential combined DIF attention layer and feed-forward layer. And the block structure is the same as SUSREC, except that we replace the original multi-head self-attention with the multi-head DIF attention mechanism. And each DIF block involves 2 types of input, namely current item representation and auxiliary set information embeddings, and then output updated item representation. In the DIF attention layer, all attributes attend upon themselves to generate the decoupled attention matrices, which are then fused to the final attention matrices. The decoupled attention calculation improves the model's expressiveness through breaking the rank bottleneck of attention matrices, and this matrices is bounded by the head projection size DH. It also avoids inflexible gradients and certain cross relationships among different attributes and the item to enable a reasonable and stable self-attention. And with the final item representations that encode the sequence information with the help of set information, we take the representation of the last item to estimate the probability of user U to interact with each item in the item set. During training, we propose to use auxiliary attribute predictors for attributes to further activate the interaction between auxiliary set information and item representation. Here, finally, we compute loss using cross entropy to measure the difference between prediction and ground truth. The final loss function is the weighted summation of item loss and attributes prediction loss. We also use a hyperparameter lambda to control the contribution of each loss. We conduct some experiments on 4 real-world datasets, and we follow the same pre-processing steps used in previous papers. We just remove all atoms and users that occur less than 5 times in this dataset, and we evaluate model performance in a full ranking manner for fair comparison. We choose 2 types of state-of-the-art methods for comparison, including strong basic sequential recommendation methods and recent competitive set information integrated methods. And as you can see, it's clear that our proposed method consistently outperforms both state-of-the-art sequential recommendation methods and set information integrated SR models on all these 4 datasets in terms of all evaluation metrics. And with a simple and effective design, we argue that DAF and AAP can be easily incorporated into any self-attention-based SR model and further boost the performance. So we conduct experiments on 2 representative models, Sus-like and Birdfoot-like. As shown in this table, with our design, the enhanced models significantly outperform the original models. So this demonstrates that the proposed solution can potentially make more impact as a plug-in module in state-of-the-art SR models. We also conduct ablation study for every proposed components on sports and job datasets. And here we have 3 observations. First, DAF is the most effective component in our framework. This observation verifies that decoupled set information significantly improves the representation power of attention matrices. Secondly, only using AAP on the Fourier integrated embedding-based method can't always improve the performance. Third, the AAP-based training paradigm can further improve the model performance when combined with DAF. This verifies its capacity to activate the beneficial interaction and improve the performance. We also conduct a study for different attributes to explore the contribution of different kinds of set information. We found that both item-related attributes can help the prediction by a large margin. This demonstrates that the effectiveness of set information fusion. Also, the combination of 2 attributes can further improve the performance slightly. In hyperparameter study, we first explore the effect of balance parameter lambda in the loss function. For all these 4 datasets, the best performance is achieved when the balancing parameter lambda is 5 or 10. We also explored the effect of attributes embedding sets. We observed that in most cases, The performance is consistent across different choices of the attribute embedding sets for category. Based on this, it is possible to greatly reduce the model complexity by setting the attribute embedding sets to a smaller value. We also explore the effect of the fusion function. We found that our method is robust to all different fusion functions. Finally, we visualized attention matrices of test samples from the YOP dataset. We found that the decoupled attention matrices for different attributes show a different preference for capturing data patterns. And the fused attention matrix could adaptively adjust the contribution of each kind of set information where the decoupled attention matrices and pick crucial patterns from them. Thanks for your listening. If you have any questions on our paper or course, please feel free to contact us.